It begins, as many cosmic mysteries do, with a faint dot in the dark. On July 1st, 2025, a small telescope in Chile, part of the Atlas survey system, detected something unusual. A moving speck of light crossing the background stars at a speed no ordinary comet could match. At first, it seemed like just another discovery in the endless data stream of spacewatch observatories. But as more measurements came in, one fact became clear. This object was not from our solar system. Its orbit wasn't elliptical, like those of our comets or asteroids. It was hyperbolic, open-ended. That meant it had come from the stars. Astronomers named it 3I Atlas, the third known interstellar object ever detected after Oumuamua in 2017 and 2I Borisov in 2019. The 3I means it's the third interstellar visitor ever confirmed. The discovery electrified the astronomical community because each one of these objects is like a message from another solar system, material that has traveled light years before wandering into our neighborhood. At first, scientists were thrilled. Unlike Oumuamua, which was small, fast, and frustratingly hard to observe, 3I Atlas appeared much brighter. That meant telescopes like Hubble and the James Webb Space Telescope could actually study it in detail. But almost immediately, things got weird. The motion that shouldn't exist. The path of 3I Atlas through space didn't behave like a typical comet's path. Comets follow predictable curves around the sun, their trajectories shaped by gravity and small pushes from the gases they release. But 3I Atlas didn't just curve, it accelerated, and not in a way that matched normal outgassing patterns. Its brightness fluctuated irregularly. Sometimes it shone brighter than expected, other times it dimmed too quickly. Spectral analysis revealed a composition unusually rich in carbon dioxide and poor in water ice, a chemistry unlike any comet we've studied in our solar system. The object's shape and structure remain unknown, but one theory suggested it might be a fragmented body, perhaps an icy crust surrounding a denser metallic core. Another hypothesis, it's covered in materials that sublimate very quickly, creating strange jets that alter its path unpredictably. Yet with all those explanations, the data didn't fully add up. That's when the headlines began to appear. NASA can't explain interstellar objects' strange motion. Could 3I Atlas be an alien probe? The pattern was familiar. Ever since Oumuamua defied conventional explanations, every new interstellar visitor draws the same whispered question: what if it's not natural? A visitor from the unknown. To understand why 3I Atlas matters so much, you need to understand how incredibly rare such visitors are. Space between the stars isn't empty. It's filled with debris, dust, frozen rocks, chunks of planets ejected during the chaotic birth of solar systems. Most of it never comes anywhere near us, but every few decades, maybe even centuries, one of these fragments wanders close enough for Earth's telescopes to catch a glimpse. That's what makes interstellar comets so valuable. They are physical samples of other star systems, untouched since their creation. When scientists realized 3I Atlas came from another solar system, the race began. Observatories around the world, in Hawaii, Chile, the Canary Islands, and orbiting in space, all turned their eyes toward it. Spectrometers measured its light to decode its chemistry. Infrared instruments looked for heat. Radar tried unsuccessfully to bounce signals off it to determine its size. From the combined data, astronomers estimated it could be several kilometers across, roughly the size of a small mountain. Hubble captured a stunning image, a tiny glowing nucleus surrounded by a faint halo of gas, the comet's coma, with a delicate tail stretching behind it. To the untrained eye, it looked beautiful and ordinary. But to scientists, it was anything but ordinary. The chemical fingerprints didn't match anything in our solar system. Some materials in its spectrum could only form in environments much colder than any region near our sun, evidence that it had been born in the distant outskirts of another star's domain. The alien craft hypothesis. Then came the twist. A familiar name re-entered the conversation. Avi Loeb, the Harvard astrophysicist who famously suggested that Oumuamua might have been an alien probe, a defunct light sail, or some sort of manufactured object. He argued that 3I Atlas showed similar anomalies: strange acceleration, irregular brightening, and a non-gravitational trajectory that standard models struggled to reproduce. He proposed, cautiously he said, that perhaps this too could be a piece of alien technology. His reasoning was simple. If interstellar visitors are truly random rocks, why do the first few we found all behave oddly? Could it be that the universe is full of technological relics, probes sent eons ago by civilizations far older than ours, drifting between the stars until chance brings them to us? It's an intoxicating idea, and one that captures the public's imagination instantly. But science demands evidence. NASA and the European Space Agency quickly released statements clarifying that so far there was no evidence of artificial origin. All observed behaviors, from the acceleration to the chemical mix, could be explained by complex but natural cometary physics. But still, even within NASA, some scientists admitted, we can't explain everything yet. That small gap between known and unknown is where imagination takes root. The power of mystery. Humanity's fascination with alien visitors runs deep. When Oumuamua was first discovered in 2017, it tumbled through space with no tail, no gas jets, and an inexplicable boost in speed after passing the sun. That object sparked endless debate, documentaries, and even a best-selling book arguing that it was built by another civilization. Now, with 3I Atlas, history seemed to repeat itself. A new interstellar object, new anomalies, new speculation. But most astronomers urge caution. They point out that comets are chaotic by nature. Their motions depend on how volatile materials inside them vaporize. Tiny jets of gas can nudge a comet's path in unpredictable ways. And when you're measuring from hundreds of millions of kilometers away, small uncertainties can look like major mysteries. In other words, weird doesn't mean alien. Still, what makes 3I Atlas special is not just its mystery, but what it represents: proof that interstellar objects are not rare. They may pass through our solar system more often than we realized. We just weren't looking carefully enough before. Now that telescopes like Vera Rubin Observatory and JWST are online, we might soon detect dozens more. Each one will carry the chemical fingerprints of its home system, a cosmic postcard from another sun. The science behind the spectacle. Let's strip away the sensationalism for a moment and look at what scientists actually know. 3II Atlas follows a hyperbolic orbit with an eccentricity greater than 1. Its velocity relative to the Sun is about 26 kilometers per second, too fast to be bound by the Sun's gravity. Spectroscopic data show strong emission from carbon dioxide, CO2, and carbon monoxide, CO, but comparatively weak signals from water, H2O. That's unusual, but not impossible. It suggests the object formed in an environment where water ice was scarce, but CO2 was abundant. Perhaps the outer edge of a cold protoplanetary disk around another star. As it approached perihelion, its closest point to the Sun, it brightened rapidly, then dimmed just as fast. This could indicate it partially fragmented, exposing fresh ice that vaporized quickly before stabilizing again. Astronomers saw similar behavior with comets like C/2019 Y/4 Atlas, which broke apart in 2020. So although strange, the pattern isn't unprecedented. In short, the simplest explanation fits best. 3II Atlas is likely a comet, just one with unusual chemistry and an unpredictable personality. But, as every scientist will tell you, likely doesn't mean certain. Why the UFO narrative persists. If the scientific case for an alien spacecraft is weak, why does the idea persist? Because it taps into something deeper than data, a longing for connection and mystery. We live in a universe that feels both vast and lonely. When a rock from another star system appears, it feels almost personal, as if someone or something out there is reaching back. The fact that 3II Atlas behaves strangely only amplifies that feeling. Media also plays its part. A headline that says NASA studies unusual comet chemistry doesn't go viral. But AlienProbe nearing the Sun spreads like wildfire. Even when the article itself clarifies there's no proof, the seed of wonder has already been planted. And, to be fair, skepticism cuts both ways. Science advances by questioning assumptions. Once, lightning was thought to be divine. Now we know it's electric discharge. Perhaps one day we'll find that at least one interstellar visitor truly was artificial. Until then, it's healthy to keep both skepticism and imagination alive. The broader cosmic context. 3II Atlas also reminds us that our solar system isn't isolated. It's part of a galactic ecosystem. Objects are constantly exchanged between stars, ejected by gravity, captured temporarily, or simply drifting. Each interstellar visitor tells a story of its home system's birth and evolution. By studying 3II Atlas, scientists can test models of how planets form. For instance, the ratio of CO2 to H2O reveals what temperatures and pressures existed in its natal disk. That helps refine our understanding of exoplanet composition and habitability elsewhere. In other words, even if it's just a comet, It's a priceless clue in the grand puzzle of cosmic origins. NASA and ESA have even floated the idea of future missions capable of intercepting interstellar objects. Imagine a spacecraft pre-positioned in space, ready to launch interceptors when the next visitor is detected. We could sample the material directly, touch the chemistry of another solar system. It's ambitious, but after 3II Atlas, scientists agree it's time to prepare. Between facts and faith. As we watch 3II Atlas fade into the darkness beyond the sun, one truth remains. We don't know everything. For all our telescopes and equations, space still humbles us. The object will never return. Its path leads back into the void between stars. And in that void, it carries with it our curiosity and our questions. Was it truly just a comet, or could it be something more? The evidence leans strongly towards the natural explanation. But the beauty of science lies in its openness. It never closes the door entirely. Until proven otherwise, we assume nature, yet we keep our eyes open for the extraordinary. Maybe one day another object will appear, one that sends back signals or displays symmetry no rock could have. Maybe that's when we'll know we're not alone. But even if that day never comes, 3II Atlas has already done something profound. It reminded us that we live in a connected galaxy, where worlds send fragments of themselves drifting across the cosmos, uninvited but deeply welcome. And so, as this mysterious traveler continues its silent journey back to the stars, we're left with the same timeless feeling that has always driven exploration, a mix of wonder, humility, and the thrilling question, what else is out there? Don't forget to like, share, and subscribe to WiseUse, where the mysteries of science meet the vastness of imagination, and every story brings the universe a little closer.